Good morning, my dear friends. The last problem in this chapter we'll try to see now. Okay, a pre-tensioned beam 200 mm into 300 mm is pre-stressed by 10 wires of 7 mm diameter. Okay, 10 wires are there and each wire is having 7 mm diameter. Okay, initially it is stressed to 1200 Newton per mm square. Okay, this is the pre-stress he has given with their centroids located 100 mm from the soffit. In a sense, from the bottom of the beam, they are kept at 100 mm. Okay. Find the maximum stress in concrete immediately after transfer. Okay. Allowing only for elastic shortening of concrete. Okay. So what is exactly it is, we'll try to see it afterwards. Also, if the concrete undergoes a further shortening due to creep and shrinkage, while there is a relaxation of 5% of steel stress, okay, estimate the final percentage loss of stress in the wires using the Indian Standard Code 1343 regulations using the following data. Baba, he has given some of the datas. Okay, so the data I will show you now. What data he has given is, see now, he says that 28 days cube strength of concrete FCU is 42 Newton per mm square. ES, Young's modulus of steel, is 210 kilonewton per mm square. Young's modulus of concrete EC is 5700 into FCU raised to 1 by 2 Newton per mm square. Because FCU value you know here now, you can put it and you can find the value of EC. Okay. Cube strength of concrete at transfer FCI is 31.5 Newton per mm square. Ultimate creep strain is given by Baba epsilon CR. He has given this equation. Okay, sir. Now it is mm per Newton per mm square. Okay, where HA is surrounding humidity. It is 0.8, and total residual shrinkage strain is 2 into 10 to the power of minus 6. Okay, sorry, minus 4. Okay, he has given all these details. So now by using these details, he has asked you to calculate all the losses. So now he says that the cross sectional area is 200 mm by 300 mm, and he has kept the cables at 100 mm from the soffit. 100 mm from the soffit. So now you can, I think you can easily calculate the eccentricity. Okay, this distance is, I think, 150. 150 minus 100 mm will give me eccentricity. Eccentricity is now 50. Okay, you can easily write eccentricity as now 50. So now area can be now easily calculated. Moment of inertia is BD cube by 12. That also can be now easily calculated. He has given EC as 5700 into FCU raised to 1 by 2, or under root of FCU. It is now 5700. FCU value he has given it as now 42. I think FCU, he says in the problem, it is 42 Newton per mm square. So you can easily fill the value here now, and you can easily calculate your EC value. EC value is so much. Okay. So once I know EC value, okay, ES by EC will give you your modular ratio. So you can easily calculate your modular ratio as 5.7. Okay. Also, area of steel, he says that there are 10 wires of 7 mm 5. Okay, 10 into 5 by 4 into 7 square. Okay, so it will give me area of steel. Therefore I can calculate now pre-stressing force P. Okay, so it is the pre-stress into area of steel, Fs into As. Okay, will give me Fs. He says that in the problem it is stressed to 1200 Newton per mm square. Okay, area of steel, you know, it is so much. Okay, so Fs into area of steel will give me pre-stressing force, initial pre-stressing force as 4618400 okay, newtons. So now I want to calculate the stress in concrete at the level of steel. Steel is laid at an eccentricity of 50 mm from CGC. Am I right? It is laid at an eccentricity of 50 mm. So now at this level, I want to calculate the FC. Okay. So now it is a P naught by A plus or minus P naught EY by I. So P naught you know. Okay. Just now you have calculated P naught value. Area of concrete you know, again P naught value, eccentricity is now minus 50, y value is now again at this level of CGS I want to calculate. CGS lies at a distance of minus 50. So now minus 50 is your y value, I value also I know. Okay, so it will give me 10.25 Newton per mm square as the stress Fc. Okay, so now we shall try to calculate the loss of stress due to elastic deformation. Okay, elastic deformation loss is given by m times Fc. So now m value you know, Fc value just now you have calculated, it is so much. So it will give me, this is the loss. Okay, so now Baba, as soon as the elastic shortening loss occurs, okay, now I want to calculate how much is the force in wires immediately after transfer. Oh sir, now immediately after shortening effect, how much is the force? Baba, 1200 Newton per mm square is the stress you have applied. Am I right? Minus, this is the loss of pre-stress due to elastic shortening. Okay, so this will give me how much is the stress has remained. Okay, stress into area of steel. Okay, it will give stress into area of steel will give me how much is the pre-stressing force that has been left out. It is so much, 439311 newtons. Okay, this is the force, pre-stressing force left after the elastic shortening. Okay, so now I want to calculate stress in concrete at the level of steel after the elastic shortening has taken place. So now P by A plus or minus Py by I. Okay, P is now this value, area you know, area of concrete you know, again P value I know, eccentricity I know, Y value is now minus 50 and I value is so much. So I can easily calculate the stress in concrete after the shortening effect. Elastic shortening effect is, it is 9.76 Newton per mm square. This is the loss. Okay, this is one thing. So now also, now we will try to calculate the different losses now. Now the next loss is, okay, now the elastic deformation loss we have obtained it as now 58.49. Now I want to calculate the loss due to creep of concrete. Okay, creep of concrete is given by epsilon cc Fc into Es. Okay, by Fc you have already calculated in the previous step. Es I know, it is the Young's modulus of steel. Now creep coefficient epsilon cc can be calculated by this equation. He has given this equation in the problem itself now. Okay, 17.5. Okay, 1.25. Fill up all the values. Okay, all the values are known to you in the problem. So it is epsilon cc is so much. Okay, so now if you fill in this equation, you will get the loss due to creep of concrete. So all the values are filled. It is 84 Newton per mm square. Now the loss due to shrinkage of concrete is given by epsilon ch into Es. So epsilon ch value also you know, it is given in the problem. Es value also you know, it is so much. And the loss of pre-stress due to relaxation of steel, he has said in the problem that you can take 5% as 5% of the initial stress as the relaxation of steel. So 5% of your initial stress applied is 1200, so it will become 60 Newton per mm square. Okay, so now if you add all these losses, it will give me 265.45. So convert it now. Final stress in the wires is 1200 is the initial pre-stress you have applied, and 265.45 Newton per mm square is the total loss. If I deduct it, it will give me 934.55 Newton per mm square. Okay, so now if all I want to calculate the percentage loss of pre-stress, it is 265.45 divided by initial stress into 100. So it will give me 22.12. Okay, so now that is how you can calculate different losses. Okay, thank you very much.